Good morning, everyone. Today we are going to talk about CPU scheduling algorithms. This is one of the important topic in operating system. Before entering into the CPU scheduling, we must know what is process. So a process is a program under execution. So every process is waiting for CPU to execute. So the CPU scheduling algorithm is very important to allocate the process in a proper way. So CPU scheduling is the process by which a process is executed by the using the resources of the CPU. So the process also can wait due to the absence or unavailability of the resources. These processes make the complete use of central processing unit. So the main task of CPU scheduling algorithm is to efficiently use the CPU. So each processes are competing for CPU. So we are using some CPU scheduling algorithms to allocate the process into CPU schedulers. Then before entering into the CPU scheduling algorithm, we must know some basic technologies about process. Then first is process ID. The process ID is the first thing is to be written while solving the problem. So based on this process ID only, we can identify the process. This is the example for process ID. It can be 0, 1, 2, 3, or P0, P1, P2, P3. It can be anything. So this is the process ID to identify the process. The next thing is arrival time. What is the arrival time? Every processes are in ready queue for its execution. So when it enters to the ready queue, that is called the process arrival time. The time which is required for the process to enter the ready queue or the time when the process is ready to be executed by the CPU is called arrival time. Then burst time. The time slot which the process requires to complete the process is known as the burst time. That is, if a process is allocated to the CPU, it needs some time to complete its execution. So the time is called burst time. Then completion time. The total time required by the CPU to complete the process is known as completion time. Then turnaround time. Turnaround time means the time taken by the CPU since the process has been ready to execute or since the process in the ready queue is known as turnaround time. The formula for turnaround time is turnaround time equal to completion time minus arrival time. So this is called turnaround time. The next one is waiting time. How much time the process is waiting in the ready queue to allocate to the CPU. That is called waiting time. So the time the process has been waiting to complete its process since the assignment of the process for completion is known as waiting time. Now let's see the formula for waiting time. The waiting time formula is waiting time equal to turnaround time minus burst time. Okay, then the next one is ready queue. Then what is ready queue? The process which are ready for its execution, it is are stored in the ready queue. So the queue where all the processes are stored until the execution of the previous process. This ready queue is very important because there would be confusion in CPU when two same kinds of processes are being executed at the same time. So this ready queue will avoid this confusion. And the Gantt chart, it is very important. And this Gantt chart is used to calculate the waiting time, completion time, and turnaround time. So this is the very important concept of Gantt chart. Then modes in CPU scheduling algorithms. There are two types of modes in CPU scheduling algorithms that are preemptive and non-preemptive. In preemptive approach means if a CPU is executing some process, if any high priority job enters, it terminates the currently running process and give attention to the high priority job. That is called preemptive approach. Then let's see non-preemptive approach. Non-preemptive approach means even if a new high priority job enters into the queue, the CPU uh, give attention to the currently executing process. After the completion only, it move to the high priority job. So it never stop its execution, even if high priority job enters. That is called non-preemptive approach. These are the two important approaches in CPU scheduling algorithm. So these are the different types of CPU scheduling algorithms. First one is first come first serve, shortest job next, priority scheduling, and round robin scheduling. Okay, let's see one by one. This is the first come first serve scheduling algorithm. So let's see the table. Here, process ID, process name, arrival time, and burst times are given. Process IDs are P1, P2, P3, P4, and P5. These are the five processes, and their names are A, B, C, D, E. Arrival time means the process enters into the ready queue or it's ready for execution is called its arrival time. So the process P1 enters into the ready queue at arrival time of 0. And then process P2 is entered at time of arrival time 2 milliseconds. So likewise, for all process it is given. Then burst time. Burst time means the process P1 is need 6 milliseconds to complete its execution. So it needs 6 milliseconds of CPU executions. So process P2 needs 2 milliseconds. This is called burst time. The process needs how many milliseconds to complete its execution is known as the burst time. Already we saw that. So here the burst time for five processes are given. Now let's see how to calculate the waiting time, turnaround time, and completion time for these processes. Okay, so before I told that we are using Gantt chart to calculate the completion time, turnaround time, and waiting time. Let's see based on the Gantt chart how we calculated all those things. Okay, first one is Gantt chart. In Gantt chart, process P1 is enter because what is first come first serve? The process which is first enters into the queue will serve first. That's why this algorithm is named as first come first serve scheduling algorithm. Here process P1 is entered first. Its arrival time is 0 milliseconds. So at the time of 0 milliseconds, it enters into the queue and it needs 6 milliseconds to complete its execution. So it completes its execution by 6 milliseconds. Next, the process P2 will enter. It starts your execution at 6 milliseconds. Already we saw in the table, the process P2 needs 2 milliseconds to complete its execution. So 8 milliseconds. At the time of 8 millisecond, process P2 complete its execution. Likewise, all the three processes are complete its executions accordingly based on their burst time. This is called first come first serve scheduling. That is based on the first come basis. We are serving the process first. We are executing the process first. Now let's see how we calculated the turnaround time, completion time. So already we saw the formula for all those things. So based on the formula, we are calculating the completion time and turnaround time and waiting time. Let's see what is the advantages and disadvantages of first come first serve scheduling algorithm. First, let's see the advantages. So it is very easy to perform by the CPU and it follows just first in first out queue approach. So the disadvantage of first come first serve is not very efficient. The first come first serve suffers because of convoy effect because the process which enters into the queue will execute first. Suppose if the process is enters at last, it have to wait until all the processes has to complete its execution. So that is the only one of the problem in first come first serve scheduling algorithm. Let's move on to the shortest job for CPU scheduling algorithm. The name itself tells that the shortest job, the process with a less burst time will execute first. So that is called shortest job CPU scheduling algorithm. Let's see the example. So this is the table for a shortest job for CPU scheduling algorithm. Here also the six process, we have taken six process and their arrival time and burst times are given. Okay. How it's selected in shortest job for CPU scheduling algorithm. In first come first serve, we saw that the process which entered into the queue will execute first. Here, based on the burst time. Here, which process is having less burst time? Let's see. Process P2 is having less burst time, that is 2 milliseconds. So, the process P2 will execute first. Next one, the process P0, which is having burst time 3. So, it will execute next. So, based on their burst time, the process which is having low burst time will execute next. That is called shortest job for CPU scheduling algorithm. Then see how we calculated the completion time, turnaround time, and waiting time for all those things using Gantt chart. So I like before I said the process P2 is having less burst time, that is 2 milliseconds. So process P2 executed first. It started its execution at 0 milliseconds and it completes the executions at 2 milliseconds. Next, the process P0 is having less burst time. Already I mentioned that it needs 3 milliseconds. So it starts its executions at 2 milliseconds and complete it at 5 milliseconds. So likewise, every processor executed according to their burst time. That is why it is called the shortest job for CPU scheduling algorithm. And using this, we have calculated the completion time, waiting time, and turnaround time using the formulas which is explained before. Okay, now let's see the advantages and disadvantages of the shortest job for CPU scheduling algorithm. So it is also called as SJF. It's used because it has the least average waiting time than the other CPU scheduling algorithms. SJF can be termed or can be called as long-term CPU scheduling algorithms. And then disadvantages, the main disadvantage of shortest job CPU scheduling algorithm is starvation. So starvation is one of the negative traits shortest job CPU scheduling algorithm exhibits. and often it becomes difficult to forecast how long the CPU request will take. Then next see priority CPU scheduling algorithm. So the priority CPU scheduling algorithm is different from the remaining CPU scheduling algorithms. Here each and every process has a certain priority number. There are two types of priority values. Highest number is considered as highest priority value and lowest number is considered as lowest priority value. That is, in first come first serve scheduling algorithm, we allocate the process based on their first come and first serve. And in shortest job CPU scheduling algorithm, the process which is having less burst time will execute first. In priority CPU scheduling algorithm, each process has given some priority value. Based on the priority value, we execute the process accordingly. Either we can choose the highest priority value or we can choose the lowest priority value. Okay, let's see with the example. Here we have taken 6 processes and their arrival time, burst time are given. Also, here priority number is given. According to this priority number, we can take, if we choose the low priority values, then we will execute the process P3 first. Suppose if we are executing high priority, then we have choose the process P1. So this is the difference. According to the priority number, we start executing the process. So this is also given in Gantt chart. So according to the what according to their priority number it will be executed, and like this completion time, waiting time and turnaround time are calculated. Now let's see the advantages and disadvantages of the priority CPU scheduling algorithm. The advantages are the typical and average waiting time for the priority CPU scheduling algorithm is shorter than first come first serve, and it is easier to handle priority CPU scheduling. It is less complex. Then the disadvantage of the priority CPU scheduling algorithm is the starvation problem is one of the preemptive priority CPU scheduling algorithms most prevalent flaws. Because of this issue, the process must wait a longer period of time to be scheduled into the CPU. So the hunger problem or the starvation problem is the name given to this issue. This is the main drawback of the priority CPU scheduling algorithm. And let's see the last one, the round robin CPU scheduling algorithm. So round robin is a CPU scheduling algorithm mechanism. Those cycles are around assigning each a task a specific time slot. So based on the time quantum. So here each process has given time quantum. Based on the time quantum, the CPU executes the process. For example, if a process P1, it has a time quantum of 3 milliseconds. So the CPU executes the process at 3 milliseconds. Um, so after 3 milliseconds, it will exit the process and it take the another next process. So according to the time quantum only the CPU execute. Even if it needs, suppose if a process P1 is needs 6 milliseconds to complete its execution, but the time quantum is 3 milliseconds means the CPU execute the process P1 only for 3 milliseconds, even though it needs 3 more milliseconds to complete its execution, but it execute the process only according to their time quantum. After the time quantum expires, it will select the next process. So it will give time quantum to each process so that each process has gets preferences. So this is the main concept of round robin CPU scheduling algorithm. Here the process ID, arrival time and burst times are given. So based on the using Gantt chart, we have chosen. So here process P1, which will execute a particular time quantum, and P0 will execute particular time quantum. So based process P1 executed for 1 milliseconds, then process P0. Then even though if suppose process P1 needs some more seconds to execute the process P1 needs 5 milliseconds to complete its execution, but here the process P1 is executed for 1 milliseconds. So it need 4 more milliseconds. This is will come here. So it will come into the ready queue. Then after executing all this process, it will execute it again. Okay. So previously we saw the formula for completion time, turnaround time, and waiting time. So these are calculated using the formulas. Then the main benefits of round robin scheduling algorithm. So every process receives an equal amount of CPU time. Therefore, round robin appears to be equitable because this is the main need. Every process must have an equal amount of CPU time. To the end of the ready queue is added the newly formed process. So here the CPU will be never idle and all process gets the equal chance to be executed. So these are the CPU scheduling algorithm we saw. Let's see the next topic in next class. Thank you.